So in this lecture, we will discuss about relational algebra. So relational algebra is a procedural query language. It takes one relation or table as input and it produces another relation or table as output. It uses operators to perform queries. The operators can be unary or binary. Unary means one input produces one output. Binary means two input produces one output. The input and outputs are represented by tables. The relational algebra perform recursively on a relation. Intermediate results are also considered as relations. These are some of the relational algebra operations: select, project, union, set intersection, set difference, Cartesian product, and rename. The first thing is select operation. The select tuple that satisfy a given predicate. The notation for select operation is sigma. The P indicate, you can see here sigma, and the P will be mentioned in the subscript and R will be mentioned within the bracket. The sigma symbol is used for select operation and the P indicates proportional logical formula. So that is some of the conditions such as equal to, less than, greater than or equal to, less than or equal to, and or not, etc. Or indicates the relation, that is a table. So you can see here example, a branch, the bank input example has been given as a relation here. So here our relation will be mentioned as branch. So the input is a table with branch. So the attributes are branch name, loan number, and account. Here, what we required is we want to identify the loan amount of a particular branch name. So just give it as select branch name equal to that particular name. Here I want to select Perry-Ride branch name. So about the loan amount. So the output will be mentioned as Perry-Ride. So the loan number will be there and amount will be there. So some other examples of select operation. So previous example speaks about just we want to identify the amount of the particular branch. No condition is mentioned here. Here we are giving some condition, intersected condition. So I want the subject DBMS and the cost of the book should be equal to 450. So this is the query. Sigma subject equal to DBMS. So P is mentioned in the subscript and R is books. So then cost equal to 450 is P and books is the relation. So you can see here, it will display the textbook of DBMS where the cost is equal to 450. In the next condition, we want to take the textbook of the cost equal to 450. At the same time, year should be greater than 2010. So this is the query, subject equal to DBMS of books and cost equal to 450 of books and year greater than 2010. So the output will be mentioned for the book which is having the cost equal to 450 and the year greater than 2010. The next operation is projection operation. So it projects columns that satisfy a given predicate. So the notation for project operation will be mentioned with pi, and in the subscript it will be mentioned with A1, A2, AN. So A is nothing but it speaks about attributes and R specifies the relation or table. Here the duplicate rows are automatically eliminated as related is a set. So how to identify the projection? Just in this example, I want to mention or I want to project the author of the books. Okay. So you see here the input is the books table, that is books relation. So what are all the attributes present in the books relation? Book ID, subject, cost, year, author, but I need only subject and author means I will mention the query in the form of pi subject comma authors of book. So you can see here in the output, it will display only the two entities, one is subject and author. The next one is union operation. Suppose that there are two tuples, two relations R and S, and the union operation contains all the tuples that are either in R or S or both in R and S. That is the meaning. So at least one column in both the relationship should be common. It eliminates the duplicate tuples. The notation for union operation is R union S. U is used as the union symbol here, and R and S are relations. So you see here, we are having two relations here. One is list 1, another one is list 2. Both the list 1 and list 2, the list 1 contains the attribute of player name and team. List 2 contains the attribute of player name and sport. So what I want is, from the list 1, I need the player name, and from the list 2, I need the player name. Okay. So both the things, what are from both the relationship, what are the common player names? So that I have to display. That's why it is mentioned as pi of player name of list 1 union pi of player name of list 2. So it will display the players combined from both the relations. So who are all the players? From the list 1, we will be having Sachin, Kohli and Rohit, that is mentioned. In the list 2 relation, we are having Kohli, Rohit and Messi. Kohli and Rohit is already there, and we are taking Messi here. So this is what the union operation performed in relational algebra operation. The next thing is set intersection operation. Suppose there are two relations R and S. The set intersection operation contains all tuples that are in both R and S. So it will produce only the common element present in both the relation. So the notation will be R intersection S, where intersection is used as that N like symbol will be used as an intersection symbol, and R and S are relations. Again, two relations, two tables are there. One is list 1 and list 2. So list 1 will be having the attributes of player name and team, and list 2 will be having the player name and sport. So here what I want to identify is the common player names from both the tables. So I am giving the notation as pi player name of list 1 intersection pi player name of list 2. So who are all the common players mentioned here? That is Kohli and Rohit. That is mentioned as the output. The next thing is set difference operation. Suppose that there are two relation R and S. The set difference operation contains all tuples that are in R but not in S. So here the notation is used as hyphen, that will be used as a set difference symbol. So again, two tables are there. One is list 1, another one is list 2. List 1 will be having the attributes of player name and team. List 2 will be having the attribute of player name and sport. So what I want to perform here, I want to perform the difference operation for the player names. So here, how it will display is, it will contain all the tuples that are in list 1, but not in but not in list 2. So in list 1, we are having Sachin, Kohli and Rohit. In list 2, we will be having Kohli, Messi and Rohit. So which person is missing in list 2, which is available in list 1? That is Sachin. So that has been displayed here. The next operation is Cartesian product. Here Cartesian product is represented with the notation cross. So I want to combine each row in one table with each row in other table. So again, two tables are given here. One is list 1 and list 2. The list 1 will be having the attributes of player ID, player name and team, and list 2 will be having the team number and country name as the attributes. Here I want to combine both the tables. So it will be performed according to the matrix multiplication. So you see here, the first row of the table 1 will be combined with the first row of the table 2. And the first row of the table 1 will be combined with the second row of the table 2, and the second row of the table 1 will be combined with the first row of table 2, and the second row of the table 1 will be combined with the second row of table 2. The next thing is a rename operation. So in order to perform the rename operation, we will be using the notation called row. So for example, if you want to rename the attribute player ID, player name, and team of the table in the list 1 to ABC, so it will be mentioned with row of A, B, C of list 1. So it will be replace the player ID, player name, and team of the table list 1 to ABC. So I hope you have understand the various relational algebra operations. So in the next session, we will discuss about some more relational algebra operations. Thank you.